In Phase 2 of the CPMAI methodology, data understanding, we step into one of the most critical junctures of any AI initiative. It's where we pause to assess the data landscape, what we have, what we don't, and whether it's good enough to power a model that can truly solve the business problem at hand. AI thrives not on flashy algorithms but on quality data. And in this phase, our mission is simple: evaluate whether our data is ready, relevant, and reliable. If we build on a shaky foundation, we risk everything, no matter how good the model might be. So, what exactly do we mean by data readiness? It starts with relevance. It's not about having more data, it's about having the right data. Data that directly connects to the business objective. If you're trying to predict customer churn, then product usage logs, service interactions, and churn history matter far more than, say, browser types or ad impressions. Then comes format and structure. AI models depend on structured inputs, tabular data, labeled images, formatted text. If the data is messy, inconsistent, or in the wrong format, we need to address that before modeling even begins. We also need to understand data variety. AI often requires a blend of data types: numerical, categorical, text, images. But be cautious. Combining too many datasets too quickly can lead to what's sometimes called data spaghetti, a tangled mess that introduces noise, not insight. Now, where does this data come from? It might be internal, logs, transactions, CRM records. Or it might come from public sources like Kaggle, government databases, or licensed third-party vendors. In some cases, where real data is limited, we turn to synthetic data, data generated algorithmically to mimic real-world inputs. Whatever the source, ask, is this data available, timely, and reliable? When preparing for model training, make sure your dataset is large enough to capture all edge cases. For supervised learning, labels need to be both accurate and representative of the real world. Balance is key, especially in classification tasks. If one class dominates, your model may learn to ignore the minority class altogether. This brings us to ground truth, those verified, correct answers that the AI is meant to predict. They're often created by human labelers or derived from outcomes. And they must be accurate, consistent, complete, and up-to-date. Cross-validation or third-party checks can help ensure ground truth quality. But what if you don't have enough data? You're not stuck. You have options. First, pre-trained models. These can be adapted to your domain using a technique called transfer learning. Second, generate synthetic data, for instance, using GANs or simulation engines. Third, apply data augmentation. Rotate or flip images, paraphrase texts, or modify numerical features to artificially expand your dataset. The rule of thumb? Don't obsess over size, focus on the quality of your data and how well it represents key features. Sometimes, this phase reveals that your data simply doesn't support the original business question. That's okay. Be willing to iterate back, to revisit your Phase 1 business objectives, or rethink your modeling approach, or circle back to clean and restructure the data. Iteration isn't failure, it's good practice. Let's ground this with a few real-world examples. In a customer sentiment analysis project, the team found that only 30% of historical support tickets had satisfaction labels. That's a problem for training a supervised model. So, they got creative. They used paraphrasing techniques to generate more labeled examples and introduced synthetic training data to improve balance. In another case, a fraud detection system, they discovered the fraud labels were unreliable and the dataset was highly imbalanced. The solution? Oversample the minority class and apply SMOTE, a technique for generating synthetic minority samples. That helped create a more usable dataset without biasing the model. What should you take away from this phase? First, data is king. Without quality input, even the best models will fail. Second, iterate early. Don't wait for deployment to discover flaws, look for them now. Third, your ground truth matters. That's the target your model is aiming for. If it's wrong, everything downstream will be too. Fourth, when data is scarce, focus on data efficiency. Use what you have wisely, and expand it where it counts. And finally, stay flexible. The path to success might mean revisiting earlier phases. That's not backtracking, it's how you build a robust, scalable AI solution. So as you move into the next CPMAI phase, carry forward not just your datasets, but your understanding of what they mean, where they fall short, and how to make them work for your mission.